Welcome to today's explainer. You know, it's actually kind of wild when you stop and think about it. Have you ever sent a text to a friend halfway across the globe and just marveled at how it gets there almost instantly? We rely on this tech literally every single day, but we rarely stop to think about the nuts and bolts making it happen. Well, today we're diving into exactly that. We are going to explore the invisible, absolutely fascinating processes that let digital devices communicate across vast distances. We're breaking down the fundamental building blocks of computer networks, data communication, and data flow. So here is our roadmap for today's explainer. We're going to kick things off with the digital conversation, then break down the elements of data communication, look at directing the data flow, and finally, we'll zoom out to view the big picture, networks. Let's get into it.
All right, Section 1, the digital conversation, from face-to-face to distance.
Okay, think about when we share information locally. Face-to-face, it's easy, right? It's direct. The medium is literally just the air carrying sound waves between us, or handing a note to someone sitting right next to you. Super simple. But how do digital devices actually talk to each other across vast distances? Sending a high-definition video from a server in Tokyo all the way to a laptop in London, that requires overcoming some immense physical realities. And the answer to that challenge is data communication. Simply put, it's the exchange of data between two devices through a transmission medium. Now, what's really crucial here is the absolute necessity of both hardware and software. You absolutely need the physical stuff, wire cables, fiber optics, wireless radio systems, but they have to work in perfect tandem with smart software to make that exchange a reality. It's a total team effort.
Moving on to Section 2, elements of data communication. Let's look at the anatomy of a digital message.
Let's think about a network almost like a biological system for a second. We can break down its fundamental anatomy to understand how it lives, breathes, and functions. For literally any digital communication to happen, you need these 5 non-negotiable components: the message, the sender, the receiver, the transmission medium, and the protocol. If even one of these is missing, the whole system just falls apart. No communication happens, zero.
So let's see how these 5 elements actually interact in the wild. You've got your sender on the left side. Maybe that's your personal laptop. It transmits the message, which could be anything, right? Text, some numbers, a picture of your dog. That message travels over the transmission medium right there in the center. Copper cable, optical fiber, whatever it might be. And finally, it hits the receiver on the right. But check out those lines pointing to the protocol. That right there? That is the secret sauce. The protocol is basically the ultimate rulebook. It's a set of rules that governs data communications. It's an agreement between the devices. Because without a protocol, 2 connected devices are honestly just like 2 people trying to talk while speaking completely different languages. Imagine one person only speaks French and the other only speaks Japanese. I mean, they might be physically sitting next to each other, they can hear each other, but there is zero actual understanding happening. The protocol is their shared language.
Now, just shoving data down a wire isn't enough. For this communication to actually be effective, it has to hit 4 key benchmarks. First up, delivery. The data has to actually make it to the right destination. It sounds obvious, but it's crucial. Second, accuracy. It has to be perfectly accurate. A corrupted file doesn't do anyone any good. Third, timeliness. It needs to arrive on time, which is super important for stuff like live video streaming. And fourth, jitter. Jitter is the variation in packet arrival times. If you've ever been on an internet voice call and suddenly the other person sounds like a glitchy robot, yeah, you've experienced high jitter.
All right, Section 3, directing the data flow, managing the digital conversation.
So now that we know what makes up a message, how does it actually flow over that medium? Well, the direction of the signal flow is a huge deal. It dictates both the performance of the system and how much the infrastructure is going to cost. We generally look at 3 primary modes: Simplex, Half-Duplex, and Full-Duplex. And these sound technical, but they map perfectly to everyday things we use all the time.
Let's look at the first 2. Simplex is essentially a one-way street. Data flows in exactly one direction, sender to receiver, full stop. Think of a TV broadcast or your keyboard sending keystrokes to your computer. The computer monitor isn't sending keystrokes back to the keyboard, right? Now, Half-Duplex is a 2-way street, but it's like a bridge where only one car can cross at a time. Both devices can transmit and receive, but they have to take turns. Walkie-talkies are the classic example here. You have to let go of the button so the other person knows it's their turn to talk.
And finally, we have Full-Duplex. This is the real deal. True, simultaneous, 2-way communication. Data is flowing in both directions at the exact same time. A standard phone call is Full-Duplex. Modern Ethernet networks are Full-Duplex. This gives you maximum efficiency, But here's the catch. Because you're constantly sending and receiving all at once, you need much more robust infrastructure. So naturally, it's more complex and more expensive to set up than a simple simplex connection.
Which brings us to Section 4, the big picture, networks, connecting the world.
Okay, let's zoom all the way out. We've spent time in the weeds, looking at the micro level, just a simple exchange between two devices. But what happens when we take millions of these individual conversations and link them all together? Boom, we get a network. The formal textbook definition is a collection of autonomous computers interconnected by a single technology. Unpacking that a bit, it just means that as long as independent devices can exchange info over some kind of link, they form a network. And that link doesn't have to be copper wire. It can be fiber optics, microwaves, infrared, even satellites. From a tiny LAN in a college dorm to the massive global internet, they literally all operate on this exact foundational concept.
In the payoff for building these massive macro structures, absolutely game-changing. Networks give us incredible resource sharing, meaning a whole bunch of users can tap into the same physical printers or massive digital databases. We get centralized management, which makes rolling out security updates super easy. We get remote access, so you can grab your files from a beach halfway across the world. And ultimately, all of this drives massive cost reduction for organizations. It's a win all around.
So, I want to leave you with this thought. Given the staggering, breakneck speed at which we share resources globally today, how heavily does our modern society actually rely on these invisible, structured digital conversations? I mean, every single swipe on your phone, every streaming video, every tap of your credit card hinges entirely on these basic building blocks. Without senders, receivers, protocols, and full duplex flows, our interconnected world just stops. I hope this explainer leaves you eager to dig even deeper into the complex networks that literally run our lives. Until next time, keep questioning how the invisible world works.